Maura, you're on mute. Please unmute yourself. Yeah.
Oops, I am muted now, so you can hear me better. Okay.
Yes.
I'm Mara Petzen. Shall I start, or do you want me? Yes. Okay. So I'm the head of the chair, of software testing, and I tell you about reliable. Actually, the title in the agenda was Reliable Smart Ecosystem. Actually, it's actually a joint venture between Reliable Smart Cities and Testing Smart Ecosystems. Okay, let me actually give you the feeling. So let's talk about smart ecosystems. What are smart ecosystems? Okay, when you talk about smart ecosystem, we talk about systems that are composed of many systems that are independently owned and managed, and they actually cooperate together. Okay, so okay, I actually was surprised. You know, these are the classic example of smart ecosystem are smart cities. Okay, these are 7 pictures of smart cities. Okay, maybe somebody can tell me what are these cities? Some of these cities.
They are in common. Okay, I don't see much. Let me give you the feeling. So Singapore, Helsinki, Oslo, Seoul, Zurich, New York, Amsterdam. Okay, this is these are the 7 cities. Now you can actually see the cities,
and you see that that you know they have very little in common. You know, some are based in Asia, some in North America.
Some are bigger, some are smaller, and there is not really a common denominator.
Except that these are the top 7 smart cities according to the one of the major system of controlling this information. Okay, and okay, what does it mean that they are smart cities? We look at the cities.
We don't have much more different than any other city. You know, you have building, you have
streets, you have areas. What does make a difference in a smart city? Okay, well, in the smart city,
difference, it does not advance. In a smart city, you have people, okay, you have devices, you have
an environment, but more than that, you have the software. So what makes a city a smart city overall is a software. So when you talk about a smart city, you talk about,
but more than that, you talk about the software, large software
structure that is shared
all the different systems. You know, it's shared, so it's shared among the devices, among the environment. Well, not among the people yet, but maybe also among the people. And what happens in a smart system or in a smart city?
In a smart ecosystem, there are few exceptional important elements, which is they are not built.
It's not the owner of the smart city. There are regulators.
The city council that defines the rules, the government designs some other rules, so they actually check many different elements, but
the smart city. You know, if you ask the city government
to show you the software that manages the smart city, they don't even know what it makes, but it makes sense. Okay, so these are independently owned systems that actually live and proliferate in the system with independent constraints. And they work under unpredictable execution conditions. Nobody can tell me what happens tomorrow in Oslo, what happens the next week in Seoul. Probably people will walk around, probably cars will move around, probably business will happen. But do we know what are the different elements in a smart city? No, I mean, we cannot predict the behavior in advance. And there are emerging behavior and evolving requirements. You know, in a smart city, a city does not behave the same over and over and over. A smart city changes, evolves, and the requirements are different. And the other thing which happens more and more often in a smart city is that you don't only have the concrete infrastructure, you don't only have the people, but you have more and more AI systems. So you have basically very many interactions between people, between AI, between systems, interactions that are not predicted beforehand, but they happen in the city itself. And unfortunately, it's clear that we have unavoidable failures. Failures are unavoidable because of many different different situation. Okay, so they are unavoidable because of unpredicted, independently owned system. Let me give you the example. You know, if you have a peer-to-peer ride-sharing system, you have passengers with their own devices that are developed and managed by some companies. You have drivers with their own devices. You may have different providers. You may have Uber, you may have Lyft, and they are all owned by different people, just to shrink the smart system in a small element. You have unpredictable execution conditions. You know, for example, you may have
flash mob, which were never experienced before, and that's flash mob.
Not really something, or it's not something that you can predict or manage in advance. There are emerging behaviors. Let me actually give you the feeling of the emerging behaviors on a very small ecosystem that I like a lot, which is the system that actually monitor the behavior of, or the eating behavior of people through a smartwatch. Okay, you have your smartwatch frames your movement, your smartwatch frames what you actually have in front of you, and actually guess how many calories you actually eat in a day. Okay, and you know, my friends who developed this system actually tested that with people eating, and then they found out that sometimes you know, people use different ways to eat, and they actually have different movement, and this actually upset the whole system. But okay, it's actually different requirements, and the requirements evolve, and then people suddenly noticed that there were movement that actually the system grabbed us, that if they were eating movement, but they were not. And so you got also false information stuff, what we call an error, you know, because you have interference between different systems that bring you the wrong information. Okay? So the systems are unavoidable, and the systems are unavoidable not because any system may actually fail. System may fail even if all systems behave correctly, and that's a big challenge that we have. Okay, and I give you an example. Okay, so hopefully, okay, so I go back to the example, which is basically the example of the smart sharing system. So you have passengers, you have drivers, you have different providers, you have Uber, you have Lyft. Okay, and this is our small ecosystem. Now, suddenly you have a security alarm in Wall Street. What does it mean? It means that there will be lots of people getting out of the stock exchange market and get into the street. All these people need to get away. All these people need a ride. So there will be a huge amount of a peak of request. Not new. I mean, maybe new the alarm, but not new the peak of request. It happens many times. But then you actually have another behavior that people do not really predict very well before, which is what is called what we call the greedy drivers. What is a greedy driver? A greedy driver is an experienced driver working for any of these companies who actually understands that when there is a peak of request and the riders do not increase at the same rate, if you wait enough, you get higher rate for the ride. So greedy drivers, what they do is they do not accept the offer for the ride. This has been observed, but what happens is that at this point we have people who need a ride. You have drivers who actually wants to get offline because they want actually to get a better fare. And usually, and you have the system who try to adjust. However, in some cases, what happens is that these systems actually get in the case that the number of greedy drivers increases too much, people give up the rights, and then you get to the situation that you have what is called the ecosystem crash. Drivers correctly behave. They want to get a better fare. Passengers correctly behave. They call for the rider and they don't get the rider. The system correctly computes the fare, but since the drivers start behaving in this way, in a massive way, and the cost grows far too much, the passengers start declining the offers, and then nothing happens. Okay, and so what we do here in Constructor is we actually focus, as one of the elements of doing the research we do here, is we focus on how we test the smart ecosystems. Now, if you think about, when you talk about testing smart ecosystem, we need to test emerging behaviors. Okay, so what happens is that we are working in source software. We have long experience, half a century, almost a century of experience of testing, which is basically testing the system as it is. If you think about, no matter how good you are in software engineering, when you test, you actually have the system and you test the system. And you test the system with respect to some requirements, some specifications. So you have this dual situation where you have a system and you want to test the system with respect to the specification. Now, what happens in smart ecosystems is that you don't have a specification. You go to the city council and you ask, what is the specification of my smart city? What is the specification of smart Oslo? Okay, I can give you the rules. I can give you the rules about how you actually connect to the electricity, smart network. I can give you the rule how you behave in the traffic. I can give you the rule how the traffic signals behave. I can give you lots of many big rules, but they don't give you a specification. They simply tell you what the system are supposed to follow, not how the system behaves. And so what you do, you need to actually understand how the system behaves, some of the sources you have. What are the sources you have? Well, we tried that and we found out that if you want to know how the system behaves, you actually go and get comments, you get reviews, you get blogs, you get rating sites, you get tutorials, you get people who complain about the system not behaving the way they want. You get people who tell you how they wish the system they want to behave. Basically, you have huge amount of human readable information that is from and for people, which current testing cannot handle. Currently, what you do, you pay a massive amount of testers to learn from this information how the system behaves and manually generate test cases. Now, what we do is we are working on doing it automatically. What we are working on natural language processing. We are working on transformers. We are working on image and video processing to generate test cases and oracle assertions directly from the comments. Emerging execution conditions. Again, in a system, if you test a system, you have a system and you say, when I click my mouse, I expect my slide to change, which does not happen all the time in this talk, but it happens most of the time, okay? And so basically what happens is that you have an expected behavior. Okay, so when you test the system, you actually say, when I click, I want the slide to change. If the slide does not change, if it changes too slowly, if it changes too fast, I'm not happy. And so I have what is called a specification. I have the idea of a correct behavior with respect to a specification. Think about a smart city. I'm walking to a smart city and I want to go to, I visit Oslo. I want to see actually the Viking ship in Oslo. So I take the underground, I go to the stop, I get the bus, I get to the site, I enter the museum. What is the correct behavior? I don't have the idea of correct behavior. I have the idea of behavior which is acceptable, which is healthy. I think that, for the slides, click, change the slides. For the city, I hope to get to the destination quick enough, fast enough. I hope to actually work in this, get to the museum and not find a big crowd. I hope that the smart city tells me, look, you better wait an hour and go to the seaside and come back in an hour time to actually get the less crowd entrance in the museum. So basically, what happens is that we want to actually not just understand how the system behave correctly or when the system behave correctly, but we want to understand, predict the healthiness of the system. So what we do is actually we define a different dimension of correctness, which is not correct, it's healthy. It's something that I expect satisfy my expectation. At the same time, I actually work on an idea which is actually dynamic analysis and machine learning to infer what would be the next behavior of the system from what I measure to the system. So in a nutshell, what I do is I actually train a machine learning system to understand what is the expectation of the system in terms of its evolution to make sure that the next evolution will also behave correctly. Now, next element is, okay, let me see if, okay. Unconstrained people-system interaction. That's actually, by the way, this I click and I don't see any effect on the slide. Okay, again, take any system, any book, any manual, any paper. People talk about users. You have a system and you have users. You test the system for the users. You test the system because you expect the system to the user to click. You expect the user to type. You expect the user to read. You expect the user to react. Okay. Are you a user of the city? No, you are a person in the city. You're an individual. You're humans in the city who move and act. You do not interact with the city according to how the system wants you to interact with the system, but you actually interact with the system just because you are in the system. You are part of the system. When you walk in the street, when you line in front of the museum, when you actually change destination, when you report some failure in the city, some problem in the city, you are part of the city itself as any other component of the system. And so again, we move from the classic idea of modeling system to understand how the system behaves to model human behaviors, social behaviors, to understand how the system behaves. We actually are working with this this very well-known psychological models to actually capture the behavior of the system and make sure of the people and make sure that we can actually understand how the system behaves. It's not just like check what happens if the system moves randomly, but check what happens when the system moves as we can expect the people to move, not just normal expectation, any expectation, how we can learn how the system move, how the people move, how the people interact. And for example, in the case of our greedy driver problem, which is businessmen coming out of the stock exchange looking for a ride and the greedy drivers, okay, we can predict that since these are businessmen and we can get that they're businessmen because they have behaved in the system, then we can expect them to accept any cost for the ride to be fast at the destination. And so we can actually say, okay, look, instead of increasing slowly the cost, go ahead and increase it very fast. You double the cost. People may not be very happy, but they get a service and drivers will actually line up to serve the system. But if it's not a stock exchange problem, but it's a problem of end of the birthday party downtown Chelsea from people from the suburb, doubling the price would simply eliminate all the passengers. So basically you infer who are the people, what is the behavior of the social behavior from the actions through models of the social behavior. Now I give you the three more important element that we are investigating. Let me recall, we actually are using different machine learning approaches to actually test emerging and evolving the system in the context of the emerging and evolving requirements. We are using different kind of models to actually test the system in emerging condition, and we use yet other kind of models to test the system and the people-system interaction, what is called the human-centric systems. Now, I do have a few more minutes. I can spend a couple of days to give you the whole ideas that we are getting around, to give all this information that we work on, to give the exciting details of the machine learning model, to tell you how many times we fail with the machine learning, how many times we improve the machine learning. No, I don't have the time. I want to give you very little information about how we use natural language processing to actually deal with evolving behaviors. Okay. And I'm sure if you are interested, you can actually contact me and get more information. Let me give you this important information. We have an evolving behavior. We test the system. Now, there is someone in the system which is called an oracle, not this oracle, actually. The oracle in the system is the part of the test that actually tells you whether the result is as you expect or not. Okay, so I click on my mouse and I see the slide changing. Okay, what happens now is that I see the slide changing and I'm the oracle. I say, yes, that's the behavior that I expect. Now you want this behavior to be predicted automatically. Why you want to do that? Because I want to run not one test case, not two test cases, but millions of test cases to make sure that I test every possible behavior in the system, every possible meaningful behavior in the system. And so what I do is I try to actually have the computer telling me whether it's correct or not. Okay, now the idea is that instead of asking the people, what do you expect? I check on the web what the people expect. I check on the web and I get some important information. For example, this is a very simple information. You know, I have my ride-sharing system, Uber, for example. If you go on Uber and you ask, can I edit my pickup point? And says Uber says, oh yes, you can edit your pickup point, and you get some information. You know, you get information which is basically the information about what you want to do. Okay, contextual information, which is when the customer adjusts the pickup location. Then you get the informal association. Then the driver location must match the new customer location. So basically what I see here, I have everything I need to test the system. When the customer changes the location, the driver location must match the customer location. Great. I pay my tester and they get the tester producing the oracle, which is an assertion. And this is a big cost. Now, what I do, I want to actually generate the executable assertion. Driver location must be equal to customer pickup. Okay, doing that manually is fairly easy. What we want to do is we want to actually do it automatically. How do we do it automatically? We use this very new way of working, which is the natural language processing. And right now we actually use transformers. Okay, let's say ChatGPT if you want. Okay, what happens is that, for example, my comment says this method returns true if a thread was found. Okay. Then I have contextual information. It actually is return. This is true when the method terminates and returns something. And I have an informal assertion, which is, it must be true if the thread has been found. Now, let me go on. What I want to do is I want to create an oracle, which is search for dangers list of objects, which returns true if a thread is found. Okay, basically, what I have is I need to get someone who can read this text. Not someone who understands English, someone who actually understands that the method is called is in danger, someone to understand that in the class you have another method which is search for dangers, and someone who understands that by calling that method you actually get the automatic information whether there is a thread or not, and then implementing the oracle. Okay, now what we do is we use word embedding. What is word embedding? Word embedding tells you, puts every word or every sets of words in a virtual space. You have your virtual space. In the virtual space, you have dogs, you have cats, you have plants, you have tables, you have founds, you have search, you have ease, you have threats, you have danger. And in the virtual space, these items, these words, have a position. And if you have a position in a virtual space, you have a distance. Okay, so basically, in this word embedding, properly built, and they exist, you can find that found and search have a given distance, and thread and danger have a given distance. And then if you move from found through to thread, you move through the same distance that you actually move from search to thread. You also get the information that there is a distance between found and search, which is constant with respect to thread and danger. And you have information that found and search talk about something which is coherent somehow, and threat and danger something which is coherent. And so this system properly used can automatically understand that you want to actually search for dangers in the list of objects to actually find a thread when you return system. So you can actually automatically generate this element. And I think I actually terminated my time slot, and I see Olga is actually happy that I terminated my time slot. Okay, let me wrap up. Okay, wrapping up. We are a new, agile, small institution right now. what does it mean? We actually don't do everything, but we actually cope with problems that emerge today. Problem that emerged today, we all live, well, actually, I think it's more than 50% of the world population live in cities. There are some cities that are already considered smart cities. In 10 years' time, probably more than 50% of the population will live in a smart city. And in 10 years' time, one single failure of one single smart city will actually may change the life of millions of people. And we want to help people who actually build smart systems, build smart ecosystems to get the right tools to predict and avoid major failures. And what we do is we actually work in this idea where we have these elements, which is unpredictable events, our flash crowd. We have unpredictable behaviors like, lipstick. We have unpredictable people in the system. And we want to actually we focus on many challenges, which is understanding how the system behaves from natural language, understanding how this is predicted the behavior of the system, and model the people in the system. And we actually use all or a large set of modern technologies. And at this point, I think I stop here. I've seen some questions moving on or some comments in the chat, but I couldn't actually follow the chat as well. Maybe actually I can, Olga will summarize whether there is any question, but feel free to actually go ahead before handing on to the next speaker. Thank you.
Yeah, thank you so much, Mauro. There is no questions regarding smart cities. Dear participants, please feel free to ask them in the chat while you have such opportunity. Yeah, I remind you about the chat Q&A in our Zoom. Please, about smart cities, about programs, we will be happy to reply. Yeah, and right now I would like to move to the next topic. It's topic about our first masters in computer science and software engineering and leadership. And for this, I would like Professor Bertrand Meyer, Provost and also head of the chair of Software Engineering and Constructor Institute to elaborate a little bit more. Yeah, Bertrand, please.
Thank you very much, Olga. Thanks to Mauro. The idea is to before we talk about our master program, to give you a kind of glimpse, a snapshot of the kind of research we do at Constructor Institute. It's all in leading edge topics, and I really appreciate Mara Petzen's presentation of this really exciting but also a challenging area of making our cities smart, but making sure that they remain smart and do not cause catastrophes. So our institution, Constructor Institute, is a research and education institution, and the two parts, research and education, are closely connected. So, for example, if you come and study at Constructor Institute, you will hear more from Professor Petzen about the kind of thing that he talked about, and you will discover a number of topics and contributions and elements of, if I may use the word, wisdom, collected by the various faculty members over the years, and which we are happy to share with you. I should also mention that there are probably, I didn't see the list of participants, but there are probably a number of people who attended the presentations that my colleagues and I gave in various places recently, talking about both technical topics and our master program. So if I met you in the past few weeks in my various talks, I am happy to welcome you back to this webinar. So a bit about the context. Constructor Institute is based in Schaffhausen in Switzerland. Later on, Caroline will tell you a little more about Schaffhausen. It's part of a bigger constellation of institutions. These institutions include both companies and universities, or I should say educational and research institutions. So it's a very unique combination of for-profit entities and non-profit entities. The companies, of course, are for-profit. The educational institutions are non-profit, but everything is directed towards the same general goal, which is to improve and advance knowledge and science and research and education. So the whole edifice is the brainchild of the gentleman whose picture you see here, Serge Bell, who is a very successful entrepreneur behind the success of such companies as Cronis, which is a billion-dollar company devoted to backup and security, Parallels, Acumatica, and so on. And he's devoting the current stage of his career to building this constructor group with the intent of, as I said, advancing knowledge and education. And as far as we're concerned, we are one of the two key educational and research nonprofit elements of the group. The other part being Constructor University, which is based in Bremen, Germany. So we have a quite unique scheme with two institutions in two different countries collaborating closely in providing the best education and research we can. Next slide, please. So our one of our two programs is the CSSEL program, which is the one I'm most directly involved with. So CSSEL means Computer Science, Software Engineering, and Leadership, and it has a number of unique characteristics about which I'm going to talk briefly in the next few minutes. The scope, the program, the people, the teaching mode, and the partnerships. So let me focus in particular on the first one. The scope is original since it encompasses computer science, software engineering, and digital leadership. And the idea, actually, we can see it, I think, on the next slide. The idea of this combination, I mean, maybe the next one again. I'll come back to. Okay, one next. Okay, yeah. The general idea. Can you come back actually 2 or 3 slides? Yeah, to this one. The general idea was to do something different from most programs that exist, most master programs that exist, in which do not fill an important need of companies today. When we started the program, we inquired about within the companies in our network and in Serge Bell's network to see what the unfilled needs were, and one particularly critical unfilled need is, as we found out, for people who are technically savvy, but also have management and leadership skills. So what these companies told us is, we can find developers, that's okay, it's non-trivial, but it's doable. We can also find managers, the people typically with an MBA, a master in business administration, but they don't understand the technology. And so we have a gap because we need people who both understand the technology and can lead a project and, for example, lead a product from inception to market and beyond, which requires both kinds of skills in technology, in software technology, but that's not enough. They also require skills in management. So that's exactly what we are training. So if we go again to the next slide, the program reflects this double or triple focus, technical management and leadership. Management and leadership are quite close, but they're not identical. So this, on this slide, you have a sample of courses. Let me emphasize that it's only a sample, it's not a complete list of courses. It's designed to give you an idea of what the program is about. So you just heard a great talk from Professor Petzen on a specific part of engineering, which is smart cities, but he teaches a really interesting course on quality engineering, which is in particular devoted to testing, an area in which he's one of the world's experts and wrote one of the key textbooks on the topic. Another course, the next one on the list, is my own course, Software Construction, Architecture, and Engineering, which brings together some of the basic concepts in programming, but also in software design and in software engineering in general. And then you can see a lot of different topics in computer science in general, software engineering, artificial intelligence, machine learning, dynamic analysis, and so on. That's for the technical track. And some of these are the kind of courses that you would find in a computer science master elsewhere. What you would not find in such a curriculum, standard curriculum elsewhere, are courses like the ones in the middle column, transformational change management. Maybe this is for a business school, but it's completely different. Or leadership. On the right, you see things like agile leadership and strategic management, entrepreneurship and intrapreneurship. We encourage very much our students to become entrepreneurs themselves, and we tell them how to do so. So these are just examples. You can read the rest of the course examples, but this combination makes the originality of our program. And I think I can say on behalf of students that they really appreciate this. They appreciate this mix of software courses at the highest level and management and leadership courses. Next, in this effort, Constructor Group and Constructor Institute in particular benefits from the advice of industry leaders and in general thought leaders. So to give you a couple of examples, well, I mentioned Serge Bell already. Just below him on the left, in the left column, we have the chairman of our strategic advisory board, Konstantin Novoselov, who is a Nobel Prize in physics for his discovery of graphene, and a very close collaborator of Constructor Institute, and people like him or like Bruce Score, who is a well-known expert in agile software development and project management. People like those give us their advice, and they're very accessible, not just to the faculty and the management, but also to students. Next. It's also important to mention that we are practicing advanced technology, not just talking about it, but using advanced technology for our teaching. And in particular, we didn't wait for COVID to be alert, to be on the alert for hybrid teaching, which we have always practiced. We actually like students to be on site. It's always better when possible, but some students are remote, especially at the beginning of the curriculum when students from outside of Switzerland and the EU are waiting for a visa. So we are very agile, we are very flexible in accommodating students who are both local and remote. And in general, we have a very active mode of teaching. It's not just lectures, one of us teaching a topic. It happens, of course, but most of the time, it's much more interactive than that. Professor Petzen, for example, in his quality engineering course, puts a lot of emphasis on students' participation. Or to give an example from my own software construction, architecture, and engineering course, I actually seldom teach lectures in the standard way. What I've done is that I've recorded most of my lectures so that students are expected to watch the video of the next week's lecture in advance. And then I come and I basically sit here or stand there waiting for questions. And it makes for a much more in-depth mode of learning where students have the ability to go into the material. And even for me, as a teacher, it's a very interesting experience because you see questions coming up that the teacher would not necessarily have imagined would be in the minds of the students. So we also have, I think it's on the next slide, it's on that slide as well. Another example from my colleague, Professor Oriol, who is going to speak just now, is the capstone project, which is something that is really unique as far as I know in software engineering curricula. It's a course that lasts over 3 semesters, which makes it possible to do something really in-depth. And it's a project course in which the group of students working as a single group builds an interesting and realistic product. So it's something that in previous instances I've always wanted to do, because giving a project to students within a semester is very constraining. We don't have enough time here. We are giving ourselves the time to have a real, meaningful, realistic project. And we support this active style with tools that some other entities of the Constructor Group are building in order to provide advanced techniques for supporting learning. We can give you a brief idea of the program. So I gave you some courses before, but without a particular time order. So they are spread over these various semesters. Most of the students take the first variant, what we call the classic variant, which is a standard Bologna style, for those of you who know the European system, a 120 credit master program over 2 years, four semesters, with the last semester devoted to the master thesis, and the possibility in the summer between the first and the second year to have a summer internship, particularly in some of the companies with which we closely work. So the other two are variants of this basic scheme for students who want to complete the program in a shorter time for the fast track, or actually over a longer period for the part-time track. So the fast track compresses everything into 3 semesters, taking advantage of the summer. This is interesting, for example, for students who are on leave from a company, but the company wants them back as soon as possible. And the third variant, part-time, is interesting for students who will take the program along with continuing to work for a company. I should say that we do not advise anyone to devote less than 50% of his or her time to the program, because it's actually quite intense and intensive. So but you can take it part-time. So this is essentially the outline of the program. Now we are going to talk about a different master program, which has some of the same ideas and components, but is on a completely different topic.
Thank you so much, Bertrand. Then I'm giving word to Professor Manuel Oriol, who will tell us about the second master programs, Masters in Science in Quantum Software Engineering and Computer Science. Yeah, Manuel, please.
Yeah. Hello, everyone. I believe you can hear me. As Bertrand mentioned, we have a new master program that we launch formally this year in September. So we're very excited by it because it's completely brand new and very advanced, right? Because we have quantum and software engineering. So the idea there is that we do not only have a master program for quantum computing, but that we take the software engineering aspects as a first-class citizen in this topic, and that you, depending on your background, you might come with a background in computer science, in which case you will be learning quite a bit of quantum computing and quantum informatics, or you might come from a physics background, in which case you will learn much software engineering and still some quantum informatics. The point is we will have the same kind of blend with managerial and technical skills and leadership. And we will focus then on the quantum computing aspect with more than 60 credits that will be devoted to it. So in this case, we will have a capstone project that is specific to quantum. We will also have you will also have a master thesis that is devoted to quantum, and you will also have 3 main courses on quantum. Next. I'm also here to talk about the capstone project course, because this is one of the courses that gives quite a bit of experience to our students. So the idea here is, imagine that you might have been willing to create your own web app in the past. Well, this is the occasion to do it. And what we do, as Bertrand Meyer was saying, what we do is we take the students on a journey coming from ideation, requirements elicitation, talking to customers, to implementation, architecture, then integrating cybersecurity and machine learning, to bring this or the group of students to something that is as close as possible to a product. Next slide. So the organization of this course is over 18 months. It's formally 3 courses of 6 months. So if you need to, you will have grades every semester. And as you can see, the first semester is focusing on the mock creation, initial proof of concept, stakeholder feedback, ideation. The second semester is more about first implementation with an initial deployment. And the third semester is more about advanced and polishing. And usually the students, maybe next slide. Yeah. So generally the students really enjoy this experience because it takes them on this journey, and a few students mentioned it as, or referred to it as, the course that ties everything together, because all the work that you do, all the learnings that you have in the other courses, somehow you can apply them in this course. Just to give you an idea, the students who started in 2020, they worked on an app that is for cooking. I mean, you can imagine that during COVID, many people decided to take up cooking, so this was very fancy. We have a few more apps that have been developed in the meantime. Next. Yeah, and that sums it up basically. So you will spend a very long time, 18 months, maturing. And what is, maybe you can go back to the previous slide. Yeah, and maybe what is important here is to realize that what you will learn is not only technical, it's more, or it is also about working together, holding a project for a long time, making sure that you don't have any problems understanding how to work in teams, but also in larger tribes. So in general, what we focus on is really having larger groups. And I would like to say that this basically is coming also from my experience as someone who worked in industry. I was working for 10 years in industry, and I was also in parts there, I was also handling projects, larger projects. And what you see generally at university is only small projects, 4 to 6 people. And there you absolutely do not have the right size to tackle a very large project, which means that you also do not have the real problems that you have with larger projects. And these real problems are usually not completely technical. They are, larger projects also have many human or social interaction related problems. And this is the occasion to grow and to become simply more experienced in that field as well. Thank you. You can.
Yeah, thank you so much, Manu. And right now, I would like to give a word to Caroline to tell more about admission process, scholarships, and student life. This is a very important part because you already learned about 2 master programs, and now the time to understand how to apply. Yeah, so please, like, we have only 9 minutes left. Please ask your questions in the chat so that you can reply to most of them in the chat, and then some of them to address to speakers after all the presentations. Caroline, please join us.
Thank you, Olga. And I will be happy to give you guys, after our faculty members have spoken, told you about research, our master's programs now, what's the process for joining us? And I will try to be quick so we can indeed get to your questions. So the admissions process, the application and admissions process, we try to make it quick and simple for you. We ask for you to go onto our application portal and submit 4 documents: diploma, if you've already received it, and your transcript, motivational letter giving us a little bit more information about yourself and why you want to join us, an updated CV, resume, and a copy of an ID. And once we have those documents, then I'm in touch with you to schedule an admissions interview, which is a 20-minute interview where we ask you technical questions related to computer science and software engineering. And once that admissions interview has been done, we get back to you with admissions decision. If you've applied for a scholarship, if we're able to give you a scholarship. And this leads me to tuition, fees, and scholarship opportunities. So you see here our tuition fees for EU citizens and non-EU citizens. And indeed, we are excited to have an early bird option where if you apply by the 15th of this month, then we give you an automatic reduction. And we do have different funding options for admitted applicants. Again, once we've given an admissions decision, we can, on merit-based, we're looking at previous academic results, professional experience, and the admissions interview, give a tuition waiver, and sometimes possibly a full scholarship that also includes living stipends while students are physically located in Schaffhausen. So why are we in Schaffhausen? Where are we? We are in Switzerland, at the very northern tip of Switzerland, and it's a really great place to study. Switzerland is really well known as an innovative, modern country, and it hasn't always been this way. Sometimes the history books don't, or common knowledge, it doesn't reflect that once upon a time, Switzerland was one of the poorest countries in Europe. And it really invested in education to become what it is today. And Schaffhausen is a perfect example of that. It's really the community of Schaffhausen, the canton of Schaffhausen, has really invested in education, innovation, economic development. And we find that students find that it's a very great place to live and study. So here are some pictures of our campus. Student life, and a few alumni quotes. And you'll see that our students consistently come back and tell us how they like the flexibility of the program and the innovative nature of the program that really allows them to, as Professor Meyer already mentioned, really get good core technical skills, but as well project management, managerial skills to be able to really succeed in their next steps. So I believe that's my last slide, and we are happy to answer any further questions you might have at this time.
Thank you so much, Caroline. So we have 5 minutes for the questions, and I would like all the speakers to open cameras, and I will address the questions. Most of them, they were replied in the chat, but dear participants, please ask them like what you want to know more. And the first question I would like to address, so I've seen the question that someone already applied through our application portal. When should the students expect to get the decision after their application? Caroline, and I think it's
yes, I can field that question. So we are reviewing applications as we get them to make sure that we have all the required documents. And then, as I said, I get in touch with students to schedule the admissions interview once we've confirmed that we have all of the documents. So if you are still waiting to hear back from us, please don't hesitate to contact us at mastersoffice@constructor.org, and I'll be back in touch with you to make sure that we have all the documents that we need, and we can schedule the interview, or we can get your final decision out to you if we scheduled the interview.
Thank you so much, Caroline. One more question is about when the education year starts in Switzerland. Can you please tell a bit more when exams, when the first day of classes and so on? Yeah, Caroline, I guess it's also to you.
Yes, with pleasure. So indeed, so our academic year starts mid-September. And we have an orientation so that everyone all of our new students can get together, either virtually for those who aren't able to be in person, or on campus, and then classes starts, and then so it's mid-September, and then as you see, we classes, as Professor Meyer had mentioned, the classes are hybrid, so we have students coming in and out of campus for classes. And I hope that answers your question. I'm sorry, the sound was a little bit low, but I think maybe one of our professors also might want to chime in on a little bit more about this.
With respect to the calendar, let me just add that if you want the exact dates, it's very easy. You just Google Swiss university calendar or Swiss academic calendar, because we are aligned. I mean, all Swiss universities follow the same calendar, and we are aligned with it. So as Caroline said, the fall semester is mid-September to mid-December, and you can see all the details if you you can go to our website, but you can also just Google Swiss academic calendar and you'll find the exact dates.
Thank you so much, Caroline and Bertrand. Yeah, the next question is also, I guess, related a bit about organization. What are the opportunities for accommodation in the apartments for students near the institute? Are there single apartments or they are only for more students? And what are the approximate rents for the separate types? I see that Flavia, our program manager, has already replied, but I would like to ask Flavia or Caroline to tell a bit more, because it's an important question, where to live.
Yes,
Yeah.
sure. I can take that one. Thank you, Olga, and follow up on what I've just wrote in the chat. So at the moment, we have student flats nearby the Constructor Institute, and we have 2-room apartments or 3-bedroom apartments, which are shared between the students. We don't have single rooms, single room apartments at the moment, but perhaps in the future we could also look into that. And the rent is about 1,200 Swiss francs per month, which cover all the costs linked to the rent, plus the additional costs for electricity, internet, and other utilities that needs to be paid on a monthly basis. And these are the standard prices for 1-room accommodation in the area. Thank you.
Thank you so much, Vlade. And the next question is from Mois. I hope I pronounced it correctly. I have done master in electronics and have industrial and job experience in my home country, Pakistan, and in Europe, Austria and Slovenia. Can I join PhD with this background? Means gap in academics after like 14.
So I will answer that. It's an interesting question. So by default, we expect our applicants to have a bachelor degree in computer science, because it's the natural prerequisite to a master degree, which is largely devoted to computer science and software engineering. But, and there's an important but, we are flexible. So we are looking for good students, and we are completely open to students who have a strong background in another discipline and are willing to learn. I should sorry, I will clear my throat. I should also add that we do have students who are missing some of the fundamental background in computer science, but who have the potential to become good master students at the Constructor Institute. And for this particular case, we are starting this year a new program, which is a pre-master program, which is a 5 months program starting, I believe, in April. And the purpose is exactly to help bring students with a background in another field to the right level in computer science. So you can see it as a kind of compressed version of the key topics in computer science and software engineering that people learn in a bachelor on these topics. The cost is, I believe, 3,000 francs. Am I correct? And one of the attractions, if you like, is that we guarantee that if you successfully complete that program, then you will be admitted to the master more or less automatically. So on the one hand, if we see that you have a good enough background, we can admit you even with a bachelor degree in another field. But if we find that it's not going to be successful because you lack some of the background in algorithms, data structures, databases, operating systems, concurrency, and so on, then we have this path of taking the pre-master program that will bring you to a level where you can follow the master degree and be successful in it.
Thank you so much.
By the way, both to both master programs, both the one I presented, computer science and software engineering and leadership, and the QSEX, the quantum software engineering and computer science that Professor Oriol presented.
Yeah, thank you, Bertrand. It's very important information. And if you have questions regarding this pre-master program, please feel free to text to masteroffice@constructor.org, and Caroline will be happy to help and reply on your questions. One more question is in the chat, and I want Manuel to address and to reply on this question. I have a friend who graduated from Constructor Institute. She studied in Singapore because it was double degree. Is there any opportunity to do so again? Manuel, can you please reply on this question? What are the plans right now?
So the plans is yes, you can potentially do that. Now some of the students who did that had some funding that was associated to it, and at the moment we don't have this funding that is available. So it's a little bit unclear how this will work in a year from now, right? But relocating to NUS is not an issue. We have a number of students who did that, as you mentioned. So they recognize a number of our courses, and then students then study just one more year.
Thank you so much, Manuel. So we're a bit late. I see that there were so many questions about PhD, and there are more about questions about PhD. Please address your questions to our professors, or also to our email masteroffice@constructor.org, and we will be happy to speak with you and to explain more about PhD options. I would like Caroline just to finalize what is the application deadline, when students should apply. And
indeed, thank you, Olga. So I mentioned the February 15th early bird deadline, but we will continue to accept applications until April 30th. So depending on when you can apply, we're happy to receive your application for the early bird deadline coming up on the 15th of February or up until April 30th.
Yeah, thank you so much. We wish you good luck with your application, and we are looking forward to see you first applications and then to see you in Schaffhausen. Yeah, that's it for today. If you have more questions, please ask them through the email. Thank you so much. Bye.
Thank you. Bye.
Thank you. Bye-bye.